equation 1 becomes beta m comma n is equal to 0 to pi by 2 sin 2m minus 2 theta cos 2n minus 2 theta 2 sin theta cos theta d theta और गामा m गामा n अपॉन m प्लस n इक्वल टू 0 to pi by 2 sin 2m minus 1 theta cos 2n minus 1 theta d theta. Putting 2m minus 1 is equal to p, that is m is equal to p plus 1 upon 2 and 2n minus 1 is equal to q, that is n is equal to q plus 1 upon 2. Then we have gamma p plus 1 upon 2 gamma q plus 1 upon 2 gamma p plus q plus 2 upon 2, which is equal to 2 times 0 to pi by 2 sin p theta cos q theta d theta. So 0 to pi by 2 sin p theta cos q power theta d theta is equal to p plus 1 upon 2 gamma q plus 1 upon 2 2 times gamma p plus q plus 2 upon 2. Question: find the value of gamma half. As we know that 0 to pi by 2 sin p theta cos power q theta d theta is equal to p plus 1 upon 2 gamma q plus 1 upon 2 upon 2 times gamma p plus q plus 2 upon 2. Here putting p is equal to q is equal to 0, then we get 0 to pi by 2 d theta is equal to gamma half upon 2 gamma 1. So here integration value theta limit 0 to pi by 2 is equal to 1 upon 2 gamma half whole square, which is equal to pi by 2 is equal to 1 upon 2 gamma half whole square. 2 to cancel, then gamma half is equal to root of pi. Next question is, so that due to pi by 2 root of cot theta d theta is equal to 1 upon 2 gamma 1 upon 4 gamma 3 upon 4. Solution. We know that integration 0 to pi by 2 sin power p theta cos की power q theta d theta is equal to gamma p plus 1 upon 2 gamma q plus 1 upon 2 upon 2 times gamma p plus q plus 2 upon 2. Okay. So our question given is integration 0 to pi by 2 root of cot theta d theta, which is written as 0 to pi by 2 cos की power half theta upon sin power half theta d theta, which is written as pi by 2 sin minus half theta cos power half theta d theta. On applying formula 1, then we get 0 to pi by 2 root of cot theta d theta is equal to gamma 1 upon 2 plus 1 gamma 1 upon 2 plus 1 upon 2 upon 2 times gamma minus half plus 2 upon 2, which is equal to gamma 1 by 4 gamma 3 by 4 upon 2 gamma 1. Okay, which is equal to 1 by 2 gamma 1 by 4 gamma 3 by 4, which is equal to 0 to pi by 2 cot theta root of and d theta. Duplication formula. To prove that gamma m plus half is equal to root of pi upon 2 power 2m minus 1 gamma 2m, where m is positive, and also prove that beta m comma m equal to 2 power l minus 2m beta m comma half. Proof. We know that the formula p plus 1 half gamma q plus 1 by 2 times gamma p plus q plus 2 by 2 is equal to integration 0 to pi by 2 sin p theta cos q theta and d theta. Here putting q is equal to p, then we get gamma p plus 1 by 2 gamma p p plus 1 by 2 upon 2 times gamma p plus 1 is equal to 0 to pi by 2 sin power p theta cos power p theta d theta, which is equal to 0 to pi by 2 sin theta cos theta power common p theta. Okay, अब 0 to pi by 2 1 upon 2 की पावर p 2 sin theta cos theta power p d theta, which is written as 0 to pi by 2 1 upon 2 power p. This is 2 sin theta cos theta, which is equal to sin 2 theta p d theta. Okay, let 2 theta is equal to t, then d theta is equal to dt by 2. So which is equal to 1 upon 2 की power p 0 to pi by 2, limit also changed, sin p t dt upon 2. So 1 upon 2 की power p 1 upon 2 2 0 to pi by 2 sin p t dt, which is equal to 1 upon 2 की power p integration 0 to pi by 2 sin p t and cos power 0 t dt. By using the formula this one, we get 1 upon 2 की power p gamma p plus 1 upon 2 gamma 1 by 2 upon 2 times gamma p plus 2 upon 2. So gamma p plus 1 upon 2 into gamma p plus 1 upon 2 upon 2 times gamma p plus 1, which is equal to 1 upon 2 की power p gamma p plus 1 upon 2 gamma 1 upon 2 upon 2 times gamma p plus 2 upon 2, which is equal to, this one will be cancelled. So gamma p plus 1 upon 2 upon gamma p plus 1, 2 is also cancelled. So 1 upon 2 की power p into gamma half upon p plus 2 upon 2. Okay, so gamma p plus 1 upon 2 upon gamma p plus 1, which is equal to 1 upon 2 की power p. The value of gamma half is equal to root of pi, and gamma p plus 2 upon 2. Here take p plus 1 upon 2 is equal to m. P plus 1 upon 2 is equal to m. Then we get p is equal to 2m minus 1. So this is value convert in m, and this is value convert in 2m. So gamma m upon gamma 2m is equal to 1 upon the value of p 2m minus 1 put in here. So p 2m minus 1 root of pi upon gamma 2m plus 1 upon 2. Okay, so gamma m plus 1 by 2 is equal to root of pi 2 की power 2m minus 1 into gamma 2m. This is the first proof. Again multiplying and equation 1. Okay, multiplying both sides of equation 1 by gamma m, then we get gamma m upon gamma 2m 2 की power l minus 2m, sorry 1 minus 2m, and gamma 1 by 2 gamma m upon gamma m plus 1 by 2. So this is beta m which is equal to beta m comma m equal to 2 की power 1 minus 2m, and this is the value of beta m comma 1 by 2. This formula is known as duplication formula. Next question is for alpha beta for a beta function so that beta p plus q is equal to beta p plus 1 q plus beta p comma q plus 1. Okay, solution beta p plus 1 q is equal plus beta p comma q plus 1 equal to integration 0 to 1 x की power p 1 minus x power q minus 1 dx 0 to 1 x की power p minus 1 1 minus x power q dx. Okay, taking common, then integration 0 to 1 x की power p minus 1 1 minus x की power q minus 1, then ब्रैकेट में बचेगा x plus 1 minus x dx. So 0 to 1 x p minus 1 1 minus x q minus 1 dx beta p comma q. Oh. Next question is to show that gamma 1 upon n, gamma 2 upon n, gamma 3 upon n, and so on. Gamma n minus 1 upon n is equal to 2 pi n minus 1 upon 2 upon n power 1 by 2, where n is a positive integer. Proof. Let p is equal to gamma 1 upon n, gamma 2 upon n, gamma 3 upon n, so on, and gamma n minus 2 upon n, gamma n minus 1 upon n, which can return as 1 upon n, gamma 2 upon n, gamma 3 upon n, gamma 1 minus 2 upon n, gamma 1 minus 1 upon n. Equation 1. Okay. Writing the value of p in the reverse order. Then p is equal to gamma 1 minus n last term, gamma 1 minus 2 and second last term, and so on, gamma 3 upon n, gamma 2 upon n, gamma 1 upon n. Question number 2. Multiplying first and second. One and 2. Then we get p square gamma 1 upon n, gamma 1 minus n, gamma 2 upon n, gamma 1 minus 2 upon n, and so on. Last term, gamma 1 minus n, gamma 1 upon n. As we know that gamma n, gamma 1 minus n is equal to pi by sin n pi, then the value of p square equal to pi upon sin pi by n, pi upon sin 2 pi by n, pi upon sin 3 pi by n, and so on. Last term is sin n minus 1 pi by n. We can write as p square is equal to pi power n minus 1 upon sin pi by n, sin 2 pi by n, sin 3 pi by n, sin n minus 1 pi by n. But from trigonometry we know that sin n theta upon sin theta is equal to 2 की power n sin theta plus pi by n, sin theta plus 2 pi by n, sin theta plus n minus 1 pi by n. Equation number 3 and equation number 4. Take limit as theta tending to 0. So limit theta tending to 0 sin n theta upon sin theta is equal to limit theta tending to 0 and sin n theta upon n theta into theta upon sin theta, which is equal to n. On putting this limit in equation 4, then we get n is equal to 2 की power n minus 1 sin pi by n sin 2 pi by n sin 3 pi by n and so on, sin n minus 1 pi by n. So sin pi by n sin 2 pi by n sin 3 pi by n and so on, sin n minus 1 pi by n is equal to n upon 2 की power n minus 1. Substituting this equation in equation number 3, in equation 3 we get p square is equal to pi की power n minus 1 upon n 2 की power n minus 1, which is equal to 2 pi power n minus 1 upon n. So p is equal to 2 pi power n minus 1 by 2 upon n power half. This implies gamma 1 by n, gamma 2 by n, gamma 3 by n, gamma n minus 1 by n is equal to 2 pi power n minus 1 by 2 upon 1 की power half. Next question is evaluate 0 to 1 log gamma x dx. Solution: let I is equal to 0 to 1 log gamma x dx, as we know that the limit of 0 to a function fx dx is equal to 0 to a function f a minus x dx. So we can write as 0 to 1 log gamma 1 minus x dx, as 0 to a fx dx equal to 0 to a f a minus x dx. Okay, and adding 1 2, adding first and second, then we get 2i is equal to 0 to 1 log gamma x plus log gamma 1 minus x dx, which is written as log gamma x gamma 1 minus x dx, using the property of log m plus log n, log m into n. Then 0 to 1 limit log pi by sin pi x dx, because we know that gamma 1 minus x is equal to pi upon sine pi x. So limit 0 to 1 log pi minus log sine pi x dx, which is written as 1 upon 1 log pi x dx minus 0 to 1 log sine pi x dx, which is I1 minus I2. Question number 3, where I1 is equal to 0 to 1 log pi x होगा, pi dx equal to log pi, and I2 is equal to 0 to 1 log sine pi x dx. Here putting pi x is equal to t, then dx is equal to 1 upon pi dt. So 0 to pi log sin t dt upon pi, which is equal to 1 upon pi 2 times 0 to pi by 2 log sin t dt is equal to 2 pi minus pi upon 2 log 2, which is equal to minus log 2. Okay, from 3, 2i is equal to log pi plus log 2 is equal to log 2 pi. So I is equal to 1 upon 2 log 2 pi. This is the answer.